Vectors are a very important concept in game development, and that is why we need to cover them. Let's start with 2D representation of a vector. So I'm going to draw my coordinate system here. I'm going to have y and x. And vectors are commonly represented by an arrow, like so. In math, a vector is a geometrical object that has both a magnitude and a direction. So in this case here, the direction is given by the orientation of the arrow, and the magnitude corresponds to this length. So this is the magnitude. If you call your vector v, the magnitude is also written commonly like so, with that line on top. So in order for it to have that magnitude, the vector ends up at one point, and that point has a certain coordinates. In this case, let's say that this point is located in 1, 2, so x equal 2, and let's say that for y, this is also located in 2. Although to make it easier, maybe we could say that it's located in 3. So let's say that this is 1, 2, 3. So our vector v can be represented by the numbers 2, 3. Normally in math, a distinction is made between vectors and points, because this is how we also write a point in space, a location in space. It could be in 2 dimensions or 3 dimensions. But when it comes to working with Unity, points are also treated as vectors. So when we talk about vectors, we are going to be using that for points as well. So a location, for example, of an object will be represented as a vector. So we have now this idea of what a vector is. And there are some operations that we can do between vectors. The first operation to talk about is addition. So let's say that we have two vectors here. So we have a vector called v and a vector called u. How can we find the location or the result of u plus v? There is a geometrical way to determine that. I'll explain the geometrical way, then I'll explain the mathematical way, the actual calculation of that sum, and then I'll show you a couple of examples where that makes sense from an intuitive point of view and a game development point of view. So the geometrical way to find that result is simply grab this. Let's say that we want to add this one to this one. It doesn't matter in which order you do it. All you have to do is just draw one vector starting from the tip of the other vector. So if this vector is like that, then I'm going to draw that exact same vector, and the final point here is going to be that location. That will be u plus v. So this is v, this is u, and this is v. When it comes to the calculation, that is actually very simple. In just one dimension, if I tell you add 1 plus 2, you will know that it is 3, obviously. But if you think about it, if you had a coordinate system and you have 1, you have 2, and you have 3, if I tell you this, I'm basically telling you go to 1 first, and now go 2 more. So 1, 2, and that leaves me in 3. So it is the exact same thing that we did here. And what actually happens is that if, let's say, one of your vectors is x0, y0, and you're adding it to another vector that is x1, y1, the result will simply be just adding each one of the coordinates, like so. If you are not much of an algebra person, I can easily show it with numbers. So if we need to add, for example, 1, 2, and we need to add that to 5, 10, the final result will simply be 6 and will be 12 here. Because we are doing the same operation, we're basically telling the person or the calculation, we're telling on x go to 1 and then go 5 further from that point. So that's 6. And in y the same thing. Now a couple of examples. I'm going to start a new page to show you those examples. So let's start with the first one. you are located somewhere on a map. So let's say that this is you. This is meant to be you. And that corresponds to a certain position. So there's a certain x and a certain y. We're going to call this y0 and x0 and y0. So this is your original position. And I tell you now, move 1 to the right and move 2 up. That basically means where you are, you move 1 in this direction, and then you move 2 in this direction. So I can make that a vector. In this case, it's a vector -1. -1 because we're moving on the negative direction on x, and 2. So I'm basically adding 2 vectors here. And that is one example when you add 2 vectors. And it's obviously very intuitive that the final result will be here. So whenever you have an object in a certain position and you need to move it to a certain amount of meters or units or feet from that position, you are basically adding vectors. So that is one example. Another example is when things are moving at a certain velocity. So vectors are used obviously for velocity as well. And it's actually better to make it with just a drawing. So if you are moving in a car in this way at a certain velocity, let's call that velocity v, and if you throw a ball out of the window towards this direction, and you throw that ball at a velocity u, the final velocity, the actual velocity of the ball, for someone who's on the outside looking at that, is not going to be just on that direction because the car is moving. Let's say it's moving really fast. The ball will most likely, will obviously not move in that direction. It will actually be a sum of both vectors. So we can draw this u vector here, starting from the tip, and the final velocity of the ball, which we can call b, will be this vector here. So that is another example where you can do it. The other operation that I wanted to cover is scalar multiplication. So scalar multiplication. And that is when you multiply just a normal number to a vector. So you have, let's say, a vector v that is equal to 1, 2. And let's say that you want to multiply this vector by a number, by a value, let's say 10. The way to do that is actually quite simple. So if you have something like this, the final result is you simply multiply this scalar value by each one of the components of the vector. So the final result here will be 10 and 20. This process is called scaling a vector. Something we need to talk about is how we calculate the magnitude of a vector. This is the length of the segment. So for example, for a vector v, the magnitude is usually written like that. You won't have to do this directly when using Unity, but I think you still need to be familiar with how it is calculated. And that brings us back in Greece, this guy called Pythagoras. I'm not sure how to pronounce it, I don't speak Greek, but basically he came up with this theorem where you have a triangle that has a right angle, and if the two sides are A and B and this side is C, you have a relationship that always holds true. That means that if we want the value of C, we actually have to do the square root in here, and that gives us the value of C. When it comes to vectors, it works in the exact same manner. So if you have a vector here, and let's say that this vector is x0, y0, the magnitude of that vector, so this is v, the magnitude of that vector will be the square root of both of these. When a vector has a magnitude of 1, that is called a unitary vector. So unitary vectors have a magnitude of 1. You can make any vector into a unitary vector, and that is also something that you won't have to do manually in Unity, but the way to do it is that you simply divide each one of the components by the magnitude. So if you do that, the result of this is a unitary vector. It's expressed in this way. The result of this, the magnitude of that will be 1. So you can do the math and you will end up with this having a magnitude of 1. And why is that even important? Well, there will be times when you are making games, when you are working in Unity, when you're only interested in the direction, and then you want to multiply that direction by a certain scalar. So you could have, for example, you know that the current of the ocean goes this way, and so you can express that as a unitary vector. And then if you know the speed, you can multiply that speed by the scalar, and that will give you the velocity vector. So that is one way where this can come in handy. Now let's have a look at how Unity implements vectors. So I'm going to open the documentation and bring you to the vector3 page. The vector3 is the object that Unity uses to represent vectors. And like I said, the representation of vectors is quite broad. We're using vectors for positions and also for other values that involve an x, y, z component. For example, the scale or the rotation when it is expressed in Euler angles. So in an angle for x, for y, and for z. So if you look at the documentation, you'll see that there are some directions that already come by default, and these are all unitary vectors. For example, you can easily refer to the up direction, which is 0 on x, 1 on y, and 0 on z. So that is the up direction. These directions are going to be used very often when working with Unity. And there are other variables that you can get, like the magnitude or the normalized version of the vector, which I explained, and there are some other operations that could come in handy with working with vectors. Now, what we're going to do is work on an example, and then we're going to end up with a challenge. So let's open Unity and start a new project. I'm calling mine vectors and update, because we're also going to cover the update method here. And I've saved my scene in a scenes folder. I created an empty scripts folder, and what I'm gonna do now is actually add an object here. It's gonna be a cube. I'm gonna add that cube, and what we're gonna do is create a script that changes the position of this cube, and when it reaches a certain boundary, it goes to the other direction. So that will help us put in practice the concepts that we've seen. So in scripts, I'm gonna go and create a new script, and I'm gonna call this cube controller. So I'm gonna open that. We've spoken about start. You know what start is used for. This is run when the first frame is run in the game. So at the beginning of the game. We're gonna delete that because we're not gonna use it in this example. The update method is something that we haven't covered, but it's clearly explained here what it does. Update is called once per frame. So on each frame of your game, the update method is executed. In the documentation, the update method is under mono behavior, because it is the mono behavior class that brings this method to us that we can use. And it is explained here as well that when it is used, which is on every single frame. So it is common to add things here that you want to check at all times. And in this case, we want to be moving our cube at all times, and we're going to do that from here. So we can access the transform of our cube, because we're going to be adding this script to our cube. We can access it by typing transform. That gives me the transform of my cube. If I type position, that will give me a vector position. And if I want to move my position, so let's say up, so we said that we had this up direction, we're going to move our position up. And for that, we need to type in, we want to be adding something on each frame. And what is it that we're going to be adding? We're going to be adding vector3.up. So we're going to be adding that vector, which has a magnitude of 1. So let's start with that. And by the way, remember that plus equal this is the same as doing transform.position equals transform.position plus vector3.up. So let's start with that and you'll see what happens. So I'm going to drag my script onto my game object and I can see that it's being added and I'm going to run my game. So you can see how it went up really fast because we're moving it too fast. So let's have a speed that is not as large, and we can add that speed as a public variable and give it a default value of 0.1 f, public float speed. So what I'm going to do now is multiply this here, and as we saw, this means that each number in the vector will be multiplied. So let's try again. Let's go to cube and see how we can now enter a different value here if we want. And if we press play, our cube is moving up. So that works fine. Let's add something else to this. We can, for example, check if the location is too high, we can make it go back. So we can make it bounce up and down. To implement this up and down behavior, we need to check the position of the cube. So if the position of the cube has reached a certain number, let's say we want our cube to if it reaches 10 in the y-axis, in the vertical axis, if it reaches 10, then we want it to move down. And when it's moving down, if it reaches -10, we want it to move up. So for that, we'll be using an if statement, which allows us to check a condition. Before I write any code, I'm going to actually write pseudocode, which is instructions of what we want and the steps that we're going to take to get there. So we want our cube to move up and down between the values of -10 and the value of 10. So if we reached the position of 10, we now need to go down. To be even more precise, if we reach the value of 10 and we were moving up, then we need to now move down. Also if we reached -10 and we were moving down, so we were on our way down and we reached that point, then we need to move up. So now that it's clear what we want to do, let's actually write the code. So we're going to write an if statement here, and we're going to check the position of our object. So I'm going to type in transform.position.y. Remember that the position is a vector 3 and I can access x, y, and z in this way. So I'm going to check if this is greater and equal than 10, and also if we were moving up. If we were moving up, that means that the speed is positive because up direction is a positive direction. So we need to, I'm going to write it in English first. I'm going to write and speed is greater than 0. The way to represent and in code is with two signs like this. So this means and. Both these conditions need to be true in order for this code to execute. And what exactly is this code going to do? Well, if our speed was, say, 1 going up, now we need our speed to be -1. So we need to multiply our speed, whatever value of speed we have, by -1. So the new speed needs to be the old speed times -1. And as we've been doing, same that we did here, we're actually going to write this in a better way. So this is the same as this. We're multiplying the speed by -1. And now our cube is going down. What about the second condition? We can type it here. So if transform.position.y is less or equal than -10, and we were moving down, so and speed was less than 0. So if that is the case, we again need to change the direction, and we're using the same code. Because if the value is negative, this will make it positive. Now, it doesn't make sense to check both conditions each time, because if this condition is true, we don't really need to check the second condition. For that, we can use what's called an else if statement, where this condition is only checked if that condition was false. Now that we've written this code, let's see it in action. I'm gonna press play, which is gonna activate game mode, and it's gone all the way up and all the way down. And if you monitor the values in the transform, it will show you that it reaches 10 and then it goes back down. Before we go into challenge mode, there's only one thing that I wanted to point out. It's not relevant at this point, but it's something I want to mention and will be taken care of later in the course. Basically, update is called on once per frame, but the frame rate of your game might not always be a constant. Sometimes if you have a very slow computer, the frame rate might actually go down, so the frequency at which this is called is not constant. And that means that this speed value actually we should adjust this by the time that has passed in between these iterations. But don't worry about that now, but I just wanted to put that out there, that this is not always called at the same interval of time. So now that we've done this, let's go into challenge mode and have a try the challenge, and then I will show you the solution. All right, so the challenge starts by creating a private variable that is of type vector3. So let me show you how you can do that. So we have this public variable here. Just create another variable, but instead of float, it needs to be type vector3. And that will, you can call it however you want. You can call it, say, v. Then this next step is to add the start method back and instantiate that variable to any vector you want. What exactly does that mean? It means that you are adding again the start method. Just so we have create, you have to add the start method again. And then inside of that method, let's say that you call your vector variable v. A way to instantiate a variable is to type the equal sign. It's assign a value basically, and type in new vector3. And vector3 needs to have a value for x, for y, and for z. So you're creating a new vector in this way, and you're doing that inside of your start method. So hope that makes it more clear. Then in update, you're going to use that vector that you created instead of vector3. So we're no longer going to have vector3 here. Instead, you're going to have that vector you created. And the last step is not related to the other three steps, and it is to make it should just say y here. So ignore the x part. It should just say y. The y hard-coded values should be public variables. So what does that mean? So we have these hard-coded values is when you have numbers in your code, which is always undesirable. So you shouldn't have this 10 and minus 10. It's better to create variables for them. So you'll have a minimum value and a maximum value, and you can assign those from the inspector. So have a try of this challenge, and I'll be right here for when you finish, and I'll show you the solution. Alright, so you had a try, and it's okay if you didn't complete, because this was a very difficult challenge, and I tried to incorporate a lot of the concepts that we've seen before. And what pays off really here is just the trying aspect, because all of these things you'll get accustomed to them as you repeat over and over and over. Eventually all of these things will make a lot of sense and hopefully be very intuitive and easy as well. So let's start by creating that private variable first, which is of type vector3. So I'm going back to my code, and to create a private variable, I can either type private or I can not type anything. I'm going to choose not to type anything, just type vector3. I'm going to call my variable vector, and that's it. That's part 1. Now part 2, add the start method back and instantiate that variable to any vector you want. So I'm going to add my start method back, and Unity auto completes that for me, but I like to delete the private part. And I'm going to instantiate my vector to a new vector object. So that is new vector3, and I'm going to enter the value of 1, 1, and 1. So that is my new vector that I've created. Part 3 of the challenge is that in update, use the vector you created instead of vector3.up. So I'm going to copy that, and I'm going to paste it here, replacing the vector3.up. And we can see now, actually in Unity, we can see what will happen. We will get that happening. Last part of the challenge, make both the range in X and Y public variables. So ignore the X part, just the Y part here. Sorry about that. So the Y part is this one. And I need then two public variables. One is the minimum Y, and the other one is the maximum Y. And I'm going to give these default values that we already had before. You don't have to give them default values, that's just an option. So instead of having that -10, now I have that variable. And instead of having 10, now I have my variable here. The process of cleaning your code in this manner, of organizing your code, is called refactoring, and it's a very important process. So now our code is more clean because it doesn't have hard-coded numbers. And if we go to Unity, you'll see that Ucube, once it refreshes, it has the values that we enter, and we can obviously enter this, so I can have a much more tight range, and I can play my game, and I can see what happens now. So we have that going now. And that's all for the challenge, and that is all for the lesson. And feel free to come back to this lesson if you need a refreshment on vectors or any of these topics.